Hello friends, I am Kaustub from India. Today I am going to install keepalive in this Oxford Valley Janus 060 shunter. Shunter is good on the plain tracks where we don't have any electrical blind spots. But on the electrical blind spots it struggles, it stops. So I have decided to install keepalive in this locomotive. I have removed the shell. To remove the shell, first you need to remove these couplers. Then there are four screws which are attaching the shell to this body. So you will see over here 1, 2, 3 and 4. These 4 screws you need to remove. And then we have access to this chassis. So this is the decoder. Generally it is pasted over here, but I have just removed it. It is having one plastic coat over there. So we need to remove that plastic coat a bit to solder our keepalive. How to solder, where to solder, we will discuss later. But the problem is where to store that keepalive. So we have a couple of options. The first option I see over here, we have some space, and also we have some space over here in this gap. This I can remove this support, but that support is required to hold the speaker. Okay, so I will not remove that. I have this capacitor with me. This is 220 microfarad 25 volts capacitor, which is easily going in that what we say, the space. But what I'm thinking is, instead of having single 220 microfarad 25 volt capacitor, I will make a SMD capacitor of 100 microfarad. Sorry, I will make a capacitor bank of 100 microfarads and 25 volts of SMD capacitors. Sorry. Then that bank I will insert it over here. So I am planning to make a bank of at least 10 100 microfarad capacitor. It will be equivalent to 1000 microfarad 25 volt capacitor. It will be in parallel. So we have 25 volts for every capacitor, so we don't need to worry about the voltage. But apart from that, there is one thing I need to do. I need to add one diode and resistor combination to limit the charging current, and the diode is required to bypass that resistor when capacitor wants to deliver energy to this decoder on the blind spot. So let's see how it goes. This is the first time I am doing this, so I will keep you posted. Okay, thank you. So as we discussed previously, here we have a SMD capacitor, 100 microfarad and 25 volts. Okay, this is a very tiny capacitor. I'm placing my finger near it just to make you aware of the size of this capacitor. The nomenclature on this capacitor, you can Google it. I will not invest time in that. Now what I will do, so first thing, you see over here one strap, right, one marking. So in SMD it does mean that this is the positive side of this capacitor. So what I will do, I will make a bank of the 10 capacitors. I will place one over other and make 10 of these capacitor pasted properly. We need to make sure that we are pasting the capacitors in correct polarity. If you missed it, if you connect it in different polarity, the capacitor will burn with the reverse polarity. It is exactly opposite with the through hole capacitors. So in through hole capacitors, I will show you. Here you will have one strip over here, right? It is indicating the negative sign. The non-strip side is positive and the strip side is negative. In through hole components, but in SMD it is exactly opposite. So what I will do, I will place one upon another. I will make a bank of say 5 or 10. Let me see how I can do it. Then I will solder wire from here as well and from here as well, so it will make a bank of capacitor. I'm connecting all these capacitor in parallel, so those are from electronics or physics background, they know that if we connect capacitors in parallel, the value gets simply added with the same voltage rating. Thank you. So here we have a capacitor. I will put a very tiny piece of glue over here. I am holding camera in one hand and uh, working from my other hand. So let me paste it over here. I need to make sure that I am connecting it with the right polarity. Okay. Like that. So I will make whole bank like that. This is the third one I am doing. Let me take tweezer if I have. Holding camera in one hand and doing work is from other is very difficult. So we have a bank of these 5 capacitors, 1, 2, 3, 4 and 5. I did make sure that I am connecting this positive strip for every capacitor in my left side. So this part becomes negative and this part becomes positive. Now the complete value of this capacitor bank is 500 microfarads and 25 volts. Okay. So here I want to do a comparison. Here we have 220 microfarad capacitor with 25 volts electrolytic capacitor, and now we have a bank of 4 capacitors connected in parallel, each one with 100 microfarad. So this becomes 400 microfarads. This SMD becomes 400 microfarads. Okay, so exactly double of this. Now let me see if it fits over there or not. I think it will easily fit over there, but still there is one problem. I need to do one assembly of resistor and diode, so I am thinking how to do that. Now if you see height wise I am done with it, but still I can do same array and connect it over here, so I can make 800 microfarad capacitor total. Let me do that and come back. So friends, here we have 2 banks ready for soldering. Now the most tricky part is connecting these terminals together so that it will have a positive terminal of this capacitor, and the other side it will be having a negative side of this capacitor. Okay. So friends, here we have our diode and resistor combination ready. My soldering is not so great, I accept that. Although I am an electronics engineer, but I'm not in touch with electronic soldering since last 20 years. So I did my best, but definitely some who is daily working with soldering and electronic stuff, he can do much better job than this. I will explain the theory behind this in another video. What we need to make sure over here is, if you see, right, the below black part is diode and the above part is resistor, 100 ohm resistor. You see one ring over here, right, on the left hand side of that diode, which is a cathode, and the plain part is anode. So this anode should go to the positive end of the capacitors that we will make after some time. Sorry. So I will assemble the circuit now and then I will come back. Thank you. So here we have our capacitor bank ready. I have pasted it. Now the major part remains is soldering. So this will be our positive side where that diode anode will get connected, and this will be our negative side. So I applied some glue over here, so let it dry for some time. Let's see. So our capacitor bank is ready, friends. Here on the left hand we have positive terminal and on the right hand we have negative terminal. Okay, now the question is, where will it fit in this? So here it is still struggling. It is not like that it is not getting fitted, but it is creating some issue with the motor shaft. So other plan is, I have plenty of space over here, right, over here. So I can place it over here like this, sorry, like this, and take a wire so that I can connect it on the connector itself. Let's see how it goes. I'm not sure how I'm going to do that, but let's see. I will keep you posted. I think I've mentioned or not, I don't remember. Soldering job is not so great what I did over here. Although I'm an electronics engineer, but I left electronics field long back, 25 years ago. So my soldering is not so good, but the one who is daily doing this soldering job, daily handling electronic stuff, repairs, all those things, he can do much better soldering job over here. Thank you. So friends, I have installed that power bank, capacitor power bank, keep alive generally called, over here. You can see over here. So inside this heat shrink sleeve, diode and resistor combination in parallel is there. And let me pick up this over, keep it over here. You see, this is the capacitor bank. Now the major part is, I hopefully assuming that this upper shell will get fitted even after this capacitor bank is there in the locomotive. Let's see. I will be back. So here we have multiple blind spots, 1, 2, 3, 4. Let's see how it works over there. Performance is improved around 30 to 40%. I wish I could add more capacitors to the power bank, capacitor bank, but there is really no space. So this is how it is working. Unfortunately, I forgot to make a video when it was not having capacitor bank, but believe me, it was nightmare. For every blind spot I need to push that locomotive. I checked the DC voltage with this multimeter across the capacitor bank and it was around 15 volts. So It is good that we have used 25 volts capacitor rating, not the 16 volts. Okay, let me run it in reverse way how it works.